All right, with the calculator way for this part, what you're going to do is it's going to say problems like x squared minus x minus 6 equals 0. Okay, now what you have to do here is first and foremost, the first step before you do anything out there should be set equation equal to 0. If it's not already. Is this one already set equal to 0? And what I mean by that, does it equal 0 in the problem? Yes. Yes. If it doesn't, I want you to add or subtract all the pieces to one side. Which side you move it to doesn't matter. You just have to move it to one side or the other. Okay? So that's the first step that you do. The second step that you're going to do is that you're going to put equation into y equals. So this part right here is going to go into y equals on your calculator. Like when we graphed before. I'm going to steal Vanessa's so that I have one up in my hand. I'm going to first go and turn it on. And then I'm going to go up to y equals. Now, she already has something in this, and I want to make sure that you guys are aware of this also. When you go to y equals on your calculator, if you've got plot 1 highlighted like this one is, if you guys can see that, you see the upper corner where it says plot 1 and it looks like it's bold? That needs to be shut off. We don't want that on anymore. So what we're going to do is get the up arrow so that right now I'm on top of the plot 1 right now and it's flashing. Right, Nick? Do you see that? Now I'm going to hit enter. Now, Nick, it's still flashing, but you notice in the background it's not black anymore, is it? So if I hit the down arrow, now it's not highlighted anymore, right? It's not dark. So therefore, I just shut off the plot 1. I did not have to go into the scatter plot screen. I just shut it off because otherwise it's going to have a big mess for you. Now, how do you type in an equation into y equals? What do I do with this junk she's got it going on first?
Delete.
I clear it out. All right. How do I type this in? How do I type that into your y equals? X squared minus x minus 6, and you got it in there, right? Yep. X squared minus x minus 6. Okay? Now, because you might have adjusted the window before, I want you to hit zoom and the number 6. And when you do that, here's what should happen. You should have a screen that looks something like this. Is that about what you guys see? For those of you who have your graphing calculators here, you've seen that? Good. That's what you should have. Now, what we do with this, the third step that we're going to do is you're going to identify, bless you, where it crosses the x-axis. Which one's the x-axis? Okay, Josie finally said horizontal, but I saw about 4 people doing this. Okay, so you guys are right too. All right, so when I look at that screen then, or on your screen, this is what you see, right? How many times is it across the x-axis? Twice. Now, what you're going to do is you're going to have the calculator find it for you. I don't want you to do any work. The calculator is going to do it all for you. Here's how. The first thing that you're going to do is you're going to hit second and the trace button. Where's the trace button at? At the top, right next to the graph button. And the reason why I had you hit second first is because it needs to be in the mode of calc. You see at the top where it says calc now in that menu? The first option on that one says value. What that means is if you have a certain value of x and you want to know what the number is for y, then you put that in, not what we're going to do here. Option number 2 says 0. A 0 is another name for where does it cross the x-axis. So is that what we're going to do? Yeah. What do you think minimum and maximum is? The low point or the high point? So remember when I had you do that last chapter by hand? Could have did it with your calculator. Okay? So the fifth one up there says intersection. Intersection means if you have 2 or more graphs in there, you can figure out where they cross. Not what we're going to do here. We're going to go second trace, and we need option number 2. The 0. Now, here's what's going to happen. Right now, if you hit option 2, here's where it's at. You've got a cursor blinking right here. Bleep, 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 bleep. And it says down there, it says left bound. Does it not say that on the bottom of yours? Now, here's the button, here's the part I want to find. I want to find this. The red dot up there. Is the blue blah, 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 blah physically left of the red dot? Yes or no? That blue thing is left of red? No. Okay? If you forgot, left hand, right hand. Is the blue left of the right of the red? No, it's not. So what you need to do is you need to move it left. How do you move it left?
Arrows.
Yeah, your arrows. When is this blue blob going to be left? Probably over here somewhere, right? Would that be left of where it crosses? Yes. When it's going down the mountain or down the stream like that, then that is left of where it crosses is above the x-axis. When you get to the left over there, then I want you to hit enter. Now, here's what happened once you hit enter. Depending on the age of your calculator. Some of you have older 84s and 83s. Some of you have new color ones. Those of you with the older ones, you have this arrow that just showed up right here. Right? And some of you with the new color screen calculators, not only do you have the arrow, but then you have this little light faint line that goes like this all the way down, all the way down. Then on the bottom of the screen right now, it's saying right bound. And the cursor is blinking in the same spot that you just left it. Is that to the right of where it crosses? Is the cursor right now to the right of where it crosses? No. Clay, what do I do to move it to the right? Right. I use the right arrow. Good job, Clay. I'm so proud of you. So now I'm moving it back down. Probably somewhere in this vicinity. Because that's physically to the right of where it crossed. And then I hit enter, and this is what should happen. For those of you with the older calculators, you should have 2 arrows that are pointing at each other, right? If you've got a color screen, you also have the line going in here. And at the bottom of the screen right now, it should say guess. Like, do you want to make a guess? And you know what? No. I'd rather just the calculator tell me what the answer is. So hit enter one more time. What did it tell you was this ordered pair right there? -2, 0. Did anybody else have a different number for -2? Here's why I say that. Sometimes you could have numbers like -2.00003. That's -2. Or it might say -1.99999999997. That's also -2. You just got to be careful that you get the right, you understand that it's supposed to be -2. It's because when they were programmed, they didn't have enough pixels for this specific dot. Okay? So, here's what I want you to take away from that. What I want you to take away from that is, as I'm going downstream, like this, left bound needs to be above the line, and right bound needs to be below the line. When you're going downhill or decreasing. Now guess what we have to do? Now you got to go do the other side. So now, where do I get it again? What buttons do I hit to get the 0 thing? Somebody's saying it very faintly, like they don't want anybody to hear it. Second, Trace. Good job, Isaac, for finally speaking up for your group.
So getting out of this screen, just doesn't matter. We just press second trace from here.
Yep, and we're going to go right and find the next one. Because how many times did it cross, Tristan?
What?
How many times did it cross?
2.
Right, so we're going to find the other one now. So now we're going to go second trace, option 2 again. Here's what happened. Now it's putting a cursor point right here. But we need to find the one that's on this side over this way. So what you're going to do is you're going to move the right arrow a little bit over here. You're going to move it somewhere in this area and stop. Because is that big brown dot now left of where it crosses? Physically? Yeah. So now when you're going uphill, left is going to be below the x-axis. When you hit enter, you should get the arrow pointing this way. And if you got the color screen, you also have this little line going down, straight down. Then where do you have to move it to get to the right of where it crosses? But where do I need to stop it at, Isaac?
Above.
Good job, Isaac. I'm so proud of you. That you now need to move it to where it's above the x-axis. And then, do you want to make a guess, Isaac?
No.
No, I don't either. I'd rather you just tell me what the answer is, right? Okay, what is it? Oh, didn't you have it on your calculator? Nope. 3. Now, to be honest with you guys, realistically, the zeros do not matter in this problem. -2 and 3 are the two numbers that I was looking for. The reason why they don't matter is because in the original problem, there was never a y in this problem whatsoever. It was x squared minus x minus 6. There was no y in the problem at all. So you don't need to list the y's if you don't want to. If you just want to tell me that it crosses at -2 and +3, you're done. That's the answer. Okay? That's the buttons that you'd have to go with in order to do that. When I do this on Google Classroom, I'll put a how-to, I'll attach another PDF like I did for the regression stuff. So as far as what buttons to push again. Okay? I'll attach that to the video also. Okay? That's graphing. The second part is not graphing at all. The second part looks like this. X squared equals 36. And it's going to say, solve by using square roots. Your job on this part of the assignment is to get x by itself, and right now it's got squared. Does anybody know what the opposite of squared is? Square root. So you're going to square root both sides. The square root of x squared is x. And what's the square root of 36?
6.
You're close.
Plus or minus?
Good job, Haley. Plus or minus 6. Now, I'm going to say this about 10 times within the next 5 minutes, if not more. If whenever you need to square root to get rid of or solve in an equation, you will always have plus or minus. You will have plus or minus answers whenever you need to square root. Square rooting in equations when solving always has a plus or minus. Plus or minus always when you square root. Here's why. What's 6 squared?
36.
What's -6 squared? They're both the same, right? Therefore, anytime you square root in order to get rid of a square, you must have plus or minus. Okay? What do you think of that problem? Not too terrible? Okay. On page 99, the great one. On 3 through 12, it says solve by graphing. That's what it says for the first half. Then the second half says solve the equation by using square roots. And we just did one like the first ones, but on 13 through 20, Isaac, because you did such a good job on the other one, would you pick a number from 13 through 20?
13 to 20?
Yep.
15.
15. Thank you, Isaac. I appreciate you. Okay. Now, up on the screen right now, I have number, what did you pick again? 15?
Yep.
Okay. I have z minus 6 squared equals 25. Just so that you guys are aware of it, that's how I make my z's. Okay? I do not make it without a line in there because it was a traumatic experience for me when I was a 7th grader. My 7th grade math teacher and I got in an argument whether it was a z or a 2. So I then have to put a little line in there. So that's why you'll always see me have a little line in that z. Okay? So, first thing that you have to do when you're solving an equation, you're undoing the order of operations. Is there any adding or subtracting outside of the squared?
No.
No. Is there any multiplying or dividing outside of the squared?
No.
No. Is there squared? Yeah. How do I get rid of square? You square root it. When you square root a square, you get the inside material. So I should have z minus 6 equals, what is the square root of 25? Plus or minus 5. What happens if it doesn't come out evenly? Like what if it was the square root of 26? Would you just leave it as the square root of 26? Yes. If it doesn't break down. You know, we broke them down yesterday. The square root of 26 is 2 times 13. There's no pairs there. So we would just leave it as the square root of 26, plus or minus. So how do I solve for z? Z. Add 6. Thanks, Devin. Now, here's the part that most people screw up, and I still get this even in my college class. They leave the answer as 6 plus or minus 5. I want 2 different answers if it's that problem, or that way. What is 6 plus 5? 11. Or, what is 6 minus 5? 1. And you're done. Now, again, on some of these, it will say the square root will be left behind. So you'll have like the square root of 26. Then can you find 2 answers specifically like that? No. If you have the square root left, then you have to leave it as the square root of whatever it was. So for that particular problem, if it would have been like this, if it would have been like z minus 6 equals plus or minus the square root of, let's just say 3, just because. Then when I add 6 to both sides, you can't take away from that. So it would be 6 plus or minus root 3, and that's how you'd leave your answer. If there is a square root left behind, that's how you leave the answer for those. Those are 2 different answers. On a standardized test, it might say 6 plus root 3 and 6 minus root 3. So it might give you both answers that way, instead of just giving it to you as plus or minus. That's if after you square root it and there is still a square root left in the problem. If there's not, then you don't have to worry about that. Do you want to do another one of these?
Yeah.
Yeah? Okay, Paige, pick one. 18? Okay, on 18, Is there any adding or subtracting on the side of the squared?
Yes.
How do I get rid of a minus 5?
Plus 5.
Yep. What's 8 plus 5?
13.
So far, so good. Now, is there any multiplying or dividing on the side of the squared?
Yes.
How do I get rid of it?
Divide by 2.
Very nice. Now, here comes the dilemma. What is 13 divided by 2?
6 and 1/2.
I've heard 6 and 1/2, and I've also heard 6.5, and neither one of them I'm going to use. Here's why. 6.5, when you square root that, it's going to give you a big hellacious decimal. 6 1/2 is not user-friendly. Mixed numbers don't work here. You can stop using mixed numbers for algebra forever, okay? Those mixed numbers, we don't use them in algebra ever. So leave them as improper fractions. The only way that you can to make it easier on yourself is leave it as improper. Unless the improper reduces, just leave it as an improper fraction. Because in algebra, if it was 6 1/2, like Devin had said over here, then I'd have to convert it back to 13 halves anyway. Okay? Now, how do I get rid of square? I square root it. Right. Now, yesterday we had some of these. How do you square root a fraction?
If it cancels 6.
You do both the top and the bottom by it separately, right? That's why I like it as an improper. Does that make sense, Tim? Does the square root of 2 reduce? No. Can you leave it in the bottom?
No.
No. How do you get rid of it?
Times it by square root of 2.
And what you do to the bottom?
Must do it to the top.
Must do to the top. So x plus 2 equals plus or minus. What's root 13 times root 2?
6.
Square root of 26. All over. What's root 2 times root 2?
2.
2. We've got rid of the adding, we got rid of the multiplying, now we got rid of the squared. What's left to get rid of?
2.
How do I get rid of a plus 2?
Minus 2.
You minus 2 to both sides. So my answer is going to be x equals negative 2 plus or minus the square root of 26 all over 2. Now the reason why I left it as the square root of 26 over 2 is because does the square root of 26 reduce?
13. 2.
It's 13 times 2 and there's no pairs there, right? So I leave it that way. Do not try to find the answer. You're not going to have decimals. Okay? It does not say it'll have it as decimals. So when it says find the answer, they want exact. This is an exact solution. Your decimals would just be a guesstimate. Okay? That's how you do this section. Are you guys okay with this?
Yeah.
No? All right. So on the great one.
Bless you.